Hello everyone, I'm Alex Grigoryan. I'm a Senior Director of Engineering at Walmart Labs. And there's a big crowd coming. And I work on the application platform in Walmart Labs. So it's kind of the team that builds the framework that powers the front-end experience, a lot of the orchestration layers. And so this is really about our journey and our journey kind of through migrating to React, but more importantly about the reusability aspects of being able to kind of leverage React components to reuse across different applications, different entities. So we had a transition from kind of this Java stack into React the Node. And one of the reasons for that transition was we wanted to really be able to leverage React components and reuse them across the sites, different sites within Walmart, as well as kind of app teams within. And so we ran into lots of challenges, kind of different complexities. So this is really about our kind of philosophies. So we're going to go through kind of the philosophies that we used to for our solutions, and kind of go through what solutions we used, but along with the challenges and the principles we used to kind of come to those solutions. So the scale that we're talking about is relatively on larger end. So all the solutions might not work for you based on your size, based on your needs. I'm sure there's other ways to achieve reusability. So this is about kind of how we do it. And our scale, I think we currently have like 400 or 500 components, 300 something engineers across like 50 apps. So if you have one or two components and a dozen folks, I think a lot of our solutions might not pertain to you, but hopefully you can at least walk away with some of the guiding principles that we used for our solutions. And so this whole talk is about reusability, and it's a really key importance for our organization in particular. And that's because of kind of the way we're structured, and we're structured for productivity and efficiency. And what we do is we end up breaking up most pages that are relatively large in scope have their own team dedicated to them. And they have their own cluster. And so they're their own application fundamentally. So homepage, item page, search, cart, checkout, they have their own application on their own cluster with their own team that's focused on building features and capabilities for them. So what that means is if we want to reuse a component across like homepage and item page, it's not like we're sharing across two pages, we're actually sharing across two applications. So if you take out all the pages at Walmart that are larger in scope, there's teams that own multiple smaller pages. You're really looking at reusing components across tons of apps. So if you have something like the Carousel, and Walmart loves the Carousel. I don't know if you've been to our site, but we have a lot of carousels. I think at the home page had 9 carousels at one point, and then we toned it down. We're like, too many carousels. And so we have this carousel on the home page and item page and category and all kinds of places. And we want to be able to reuse that across all these places, not have to rewrite it over and over again. And then you take that and you multiply it by how many entities we have. So all of these are different sites as well with their own teams, their own components, and all of them have carousels too, every single one, right? So you don't want to keep rewriting it. So then when you look into other functionality, like login, well, all 3 of them have a login. They all kind of do the same thing. They all have carousels. They all have carts, checkouts, item pages. So while they look very different, we can actually reuse components. And the way so we call this capability kind of multi-tenancy or multi-brand. And that's kind of a separate topic of how we go about reusing components in different entities, because they have different styling, different content, and so I'll just touch upon it. But that's kind of one of the really big reasons that we want to reuse components, and it was such an important aspect of our focus. And our framework that we kind of open source that all of Walmart runs on, which we call Electrode, and that's why you'll see kind of the little alien logo. That's kind of the key tenets is the ability to reuse components, and that's kind of what it's built for. And that's the key reasons why we have this large focus. Even if we have this carousel and we don't reuse it, you're going to have like 20 developers build the same thing across all these different apps and entities. So let's talk about the actual solutions and the problems and what we've done. That's kind of the context. So we go into the how do you actually reuse code and the technical aspects of actually sharing, right? You can't copy paste because that's not really reusing. It's kind of like forking. So the way we go about it is all components are outside the application. All components are developed independently. Outside of the application, they're on their own repositories. And so we have an organization in GitHub. We use GitHub, the locally run version. And we have like the React components organization. And all components that are developed are not inside the applications. They're different repositories within this organization. That way, you go to one place and you know you can find every component that the company's kind of building. All of those components are then published to NPM. They're all versioned, following major minor patch. And then apps that want to use the component will then NPM install them. So that's kind of our method of just using components. So that's kind of like the first basis. So the first thing that that we have to solve is, well, I want that component and you want the component. How would we share it? And so this is kind of the method that we use to kind of go about it. And the first thing that happens is managing dependencies is hell, right? Like we're gonna have to manage all these core dependencies, libraries, build systems, testing, linting, and if any of them are different in any way, the app team can't reuse it. And if they can't, and if there is any inconsistency in some components versus other components, you immediately lose the trust of the different organizations. And they might not even try to use it, or they might run it and there's like a problem and they'll say, whatever, I'll just rebuild it. And so the consistency aspect is incredibly important. And one of the key parts of being able to be consistent is managing all the dependencies. So there's one part of managing the dependencies and making sure you know what versions of everything you're using. And then the other part of managing dependencies is how do you upgrade from like React 15.3 to 15.4 across 500 components at once. And do you really want to send these 500 pull requests, and then you're going to have to bump them up, and how do we, then every team has to kind of look into each component to see what version are they using, and it becomes very difficult very quickly. So we have this concept that we call archetypes. And so if you ever go to the Electrode website, electrode.io, you'll see archetype mentioned a lot. And it's kind of the key pieces of the framework in that the idea behind it is that you have kind of one package that will consume a lot of your other production dependencies and your dev dependencies. And that one package is versioned. And so that way you know that if I have version 5.3.2 of the archetype, all of them are the same, they all have the same core libraries. And so if you ever make a change to a core library and you will propagate it across all the other components, all you need to do is change the archetype, and all the other components will get that propagation of depending on if it's a patch and minor and how they're upgrading. And so if you want to add a new library, change libraries, move things around, and how you really manage dependencies and how teams have trust and how things are the consistency of the components is through the archetype. So we kind of talked about the different entities and how components, you might want a component for Walmart to look different from a component from Sam's Club. And the way we do that is based on the brand that you are, the component might build differently. It might pull from different CSS files. It might pull from kind of different templates. It might pull from different content. And so the components also have to build consistently, and they have to build in a specific way. So archetype is really the way to manage hundreds of components, is the easiest way that we found. And so along with, for it to build consistently and for it to act consistently, you also have to be able to kind of generate the component. So along with the archetype thinking, we also have this ability to generate new components. So when you install the archetype, you can generate other components. They all look the same, directory structure is the same, and it also solves other problems, and we'll kind of continue that in another area. So now that we have the ability to reuse, technically, we have the way to instill consistency. So teams have confidence in what they're getting, they can use the app. We have a way to manage dependencies. We have something called a Metateam within Walmart. And what's going to happen is when you have a few hundred engineers, you need a process to also have kind of code quality consistency, general principled consistency in how you build certain things. You need, and because you're affecting so many people and you're trying to keep so many people consistent, you need ambassadors from all the other teams because you need to be able to communicate broadly, widely. You need to be able to discuss changes. And so that's where we have this kind of meta team concept come from. So we have generally a few people from every single team, generally the most senior people. And these folks dedicate their time to have weekly or bi-weekly calls to discuss things that are kind of coming up with managing components, changing libraries, if we want to go in a new direction. And those individuals can then distill that to their teams, get feedback, and gives us a source to really communicate because everybody has to be on the same page. The other piece that Electrode Meta does, which I found unusual, but I felt like it really works, is any change that goes into that React components organization in GitHub, so any component that's touched, there's generally, React Meta folks, the Electrode Meta folks that will own those components, and they'll always be there to review them, give feedback, give insight, and this really helps promote that discussion and make sure things don't fall through the cracks. Because with so many people, and trying to keep everyone on the same page, things will fall through the cracks. There'll be new engineers that might not know certain things or might be trying to do something. And so it's really, you have all these ambassadors from other teams that you can use to communicate, as well as they can shepherd everyone else. And we have something called the proposal process. So with all these components, you're definitely gonna get people that, you're definitely gonna wanna get possibly duplicates of components. And you're gonna wanna change direction maybe of upgrading a library, or you have a problem and how do you want to solve that problem. And so a lot of these problems and things that we want to really get feedback from our internal community, we have a GitHub proposal process where someone will put up a proposal for a direction or a change that they want to do, or for a new component that they want to build, and the APIs around that component, and like the APIs in terms of the prop types and the interfaces. And what they want to use it for. And this really encourages discussion across the other teams to discuss like, oh, I'm going to need that component as well. And can we modify the interface to be more generic or whatnot? So before every component is kind of created, we have the system to ensure that the engineers first can talk to others, that it's all transparent and open, and there could be a collaborative discussion. And it does add a little bit of overhead, and I'll kind of get into the challenges of that. And one of the last kind of pieces of problems is discovery. If you have all these components, it becomes very difficult to discover what components you have and what you need. It becomes difficult to find out is there some kind of video player component or not, especially if they're not named properly, especially if you might have a repo with multiple components. So for the discovery process, we have kind of this tool called Electrode Explorer, which we open sourced as well. And it basically runs all of the components in our organization, on just a web application. That way anybody can kind of sift through every component, look at its documentation, its dependencies that it uses, view it, modify, and there's a little playground where you can modify the prop types, and use its interface so you can really see how it functions, see if it fits your needs. Now for this to work, it goes back to all components have to have a consistent way to showcase this. So they all have to have the ability to showcase a playground, they all have to have a demo app. And so even to do this, that archetype kind of comes into play where it's really entangled into every kind of piece and process that we have. Because the archetype ensures that all the apps have a demo. It ensures that all the applications can build the same, they can build in a way for this demo to work, and for them to show up on Electrode Explorer. So that's why the archetype is kind of this fundamental foundation for us to move forward. And so that's how we went about solving discovery. Then we gave this to product teams, designers, That way everyone now has a library fundamentally that gets built naturally as you build components, change components, and you can go back through the versions of the components. And people now are kind of on the same page of what do you have, what can I use, and designers also have something to leverage. And what's really interesting is if you have a product team that you want to showcase some components that you've built to, all you do is send them links to the Explorer and they'll be able to see it and play with it and validate if it's, if this is what they want or not. But then there's like certain problems that we've had, and that's around components breaking other teams. That's the worst thing about having dependencies and the worst thing about reusability. All of a sudden there's this reliance on other teams and they're going to break you. And it's only a matter of time. It's going to happen. And so the only way that we can kind of figure out how to solve this is through CICD. And it puts a lot of, you have to put a lot of effort in building proper tests in your application in the component. So the first pass of CI/CD can be just like component unit tests and make sure that's solid. But that doesn't guarantee breakage because you changed the component and you made sure it works. And you probably tested it on your application and that works great. But those other apps, who cares? I got features to release. And so there's no real way to guarantee that. So I think the only way that we can think of to really solve this problem is have CI/CD automatically update other applications and run their tests and run their automation. So if you if you send a PR and in the PR you can specify this is a new minor upgrade or a patch upgrade, our CI/CD pipeline wants to grab all other applications that use that dependency, automatically bump them, and run their automation suite. And kind of tell the person that's PRing which ones are passing, which ones are failing. That way, before it gets reviewed by the Metateam and before it gets accepted, you can see what the impact of that PR will do. And where we want to get to is we want to get to a place where if things pass, we want to automatically upgrade apps. That way, there's no need for engineers to even kind of go through and say, oh, these things have been updated. I know they work, and let me manually bump up their versions. But where it's much more automated than that. That way, if you have a bug fix or some feature improvement, inherently all the other applications will get it. So CI/CD is super critical. It's even more critical when it comes to archetypes. Because if you release an archetype and it breaks something, you break every single component in the app. And we've unfortunately done that a few times. And we get yelled at really quickly. So you really want to avoid getting yelled at and getting like 1,000 pings on Slack with someone broke me and it's the archetype. Because it's like instant and it ruins your day. And so the CI/CD is most important during of checking archetype versions, making sure if you're trying to bump a patch or a minor of archetype, you're not breaking any component of any app. So the CI/CD kind of scale in terms of how many apps it has to run at once for it to do this efficiently grows, where you're going to have to run dozens of apps in parallel for every PR that you do and be ready for that. But that's kind of the best machine-intensive way that we can solve it. That's not human-intensive. And so the CI/CD rules, they're critical. You can't really go about reusability without it, I feel. There's going to be a very large cost. And so then you'll end up having the different teams being able to use the different pieces, and now these teams ensure that they're not going to break each other. And so we call it this, so as you go about, let's say, implementing the ability to reuse in terms of technical sharing, and then you go about being able to, you have the archetypes, so you're going to manage dependencies, and people can discover components, and you have a team of people that you can rely on to help ensure that you're going the right path. There's still a fundamental problem that kind of comes about, and I call that kind of the ecosystem of reuse. And when you want to take reusability on as an organization, what we found is that it has to permeate every single layer of kind of management and development because it affects absolutely everything. When you're going to build something, you now have to not think of what's specific to you, but how can other people leverage this. When you want to create a component, you're going to have a discussion. You're going to have a discussion with other individuals and other organizations about can this help them or not. And when you estimate, you might have to estimate, if you're going to make, let's say, a dozen new components that you're going to make a page, you might lose a day to have the proper discussions and the thinking up front. So this really permeates every layer, and it's a change of philosophy. So you can't say, I'm going to have reuse, but I'm going to build things in silos. Or I'm going to have reuse, and I'm going to build my features, and I'm not going to put them inside the organization for everyone else to use. I'm just going to put them in my app because it's faster. Immediately, things fall apart. So even with all of this in place, it's still fragile. And I feel the only way to make it robust is if people feel the same way, have the same importance, understand what they're trying to do and why they're doing it. So it's really a philosophy change in how you build moving forward. And then there are still challenges that we have not particularly, have really good solves for. For example, when there's new libraries or new technologies that are coming out that you want to leverage, and you want to test out, is it going to work, is it not, the benefits, the pros. With everyone reusing the same thing, with everyone on the same common platform, how are you able to innovate? How are you able to get teams to really try something new versus not? And so there are some challenges, the fragility of if teams are not under the same philosophy. And what if they're in a certain team, people that really want to experiment with a new build system. And if they go down that route, everything that they build cannot be reused, and they're going to have to rebuild everything from scratch. But these are kind of the challenges that you face, and that you have to kind of talk through and figure out a process and how to do it. And so that's kind of the way in which we have been doing reuse. And I think we have 500-something components across 50 apps and a few hundred engineers. We currently have 3 tenants that are on kind of the Electrode platform. We have Walmart, grocery, and a piece of Sam's Club, and where they're leveraging this reuse. I think we have a decent system down. There's obviously room for us to really help kind of continue the philosophy and pushing that forward, improve our CICD some more. But I think that this general concept works. Thank you very much.